Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to be looking at section 2.6. We're going to be graphing lines again and looking at how to use a graphing calculator and some word problems as well that involve linear functions. So the first thing is finding the equation of a line. I like to use the slope-intercept form, y equals mx plus b. This is the y-intercept, so the b value is 5. This is the slope that they're giving me, so I will just plug in y equals negative 3.2x plus 5. They're giving me, you need two things to write the equation of a line, slope and y-intercept, and they gave it to us. So I just substitute in for slope and substitute in for y-intercept. This is called point-slope form of a line. I don't use this point-slope form. I will just continue using slope-intercept form, but if you would like to use point slope, you certainly can, but for this particular course it's not necessary to know this equation, so I don't emphasize it a lot. So find the equation of a line with the slope of 3 and the point. This time we need the y-intercept, so I'm going to start with y equals mx plus b, the equation of the line, opposed to using slope-intercept form. I'm going to keep using, instead of using point-slope form, I'm going to keep using slope-intercept form. So I'm going to plug in what I know. This says that the m value is 3, the slope is 3, and they gave me an x and a y value. So I'm going to plug in y is 7, the slope is 3, the x value is 2, and I'm simply just going to solve for b. So 7 is equal to 6 plus b. If I subtract 6, I get a b value. And remember, we need two things to write the equation of a line, slope and y-intercept. I have them. Slope is 3, so I'll put that in front of the x, and the y-intercept is 1. I think that's easier than using slope-intercept. If you want to use slope-intercept, you can. Here would be the procedure to go through, plugging in for the x value, plugging in for the y value, and then remember, you can't leave it in that form, though. You need to eventually get it into slope-intercept form, and that's simply why I start with slope-intercept form. So here's the method that we used, slope-intercept form. So find the equation of a line containing 2 points. The first thing I would do is find the slope, or find slope. By using the slope definition, y minus y over x minus x. Remember, consistency is important here, so I'm going to do point B minus point A, negative 4 minus 2, and then negative 6 minus 2. Negative divided by negative is positive, and 6/8 reduces to 3/4. So I'm going to use the slope of 3/4, and then I'm going to do the same thing I did in the previous example. Start with the equation of a line, y equals mx plus b. You could either use point A or point B, and it looks like point A is a little bit easier to use, so I'm going to say the y value is 2. The slope I just found is 3/4. The x value is 2. I'm going to write it as 2 over 1, and you'll see why in just a moment. I think I can cancel. This will give me a 3/2 here, and in order to get a common denominator, I'll change this to 4/2, which is equivalent to the 2. This way, when I subtract 3/2 from both sides, I already have a common denominator. So 4/2 take away 3/2 is 1/2. And so now I have the slope, 3/4, the y-intercept. So here comes the equation of the line. Y is equal to 3/4 x plus 1/2. And the author did something similar. Again, if you would like to see that worked out using point-slope method, here is the work for that, but I think it's easier to use slope-intercept. So here's the method that I used, plugging in for x and y, and the author used the 0.22 as well. So one of the nice things is trying to determine whether two lines are parallel or not, so you need to identify slope. There's two ways to do that. If it's in the form y equals mx plus b, then slope is simply the number in front of x. For example, this is in the form y equals mx plus b. It's written backwards, but the slope here for the first line, I'll say the slope sub 1 is 1, and the second slope, slope sub 2, well, it's not in the correct form, so I might have to play around just a little bit with this to get it into y equals mx plus b, and I can do that by adding x really quickly to both sides. So y is equal to, I'm adding x, so this would be an x minus 2, and it looks like the number in front is, so if they are the same, then they are parallel. Over here, again, I need this. This is already in the form y equals mx plus b. So it looks like the first slope is a 2, and I'm going to add 2x to both sides over here. So I can get it into y equals mx plus b, and so the slope, the second slope is also 2, and so I would say they're parallel. Over here, I would add 3 to both sides, so the first line becomes y equals 5x minus 3, if I subtract 3 from both sides. And here, I would do a couple things. Maybe subtract off 3x from both sides, so negative y is equal to negative 3x minus 2. And then if you multiply both sides by negative 1 and distribute that to every term, we'll get y is equal to 3x plus 2. So it looks like these are not parallel because the slope here is 5 and the slope here is 3. So I would say not parallel. They're not the same. So again, I'm trying to get it in that form y equals mx plus b. For the first line, I can do that by subtracting off 8, negative 6x plus 8. So it looks like the first slope is negative 6. The second slope, if you notice, is in that form ax plus by equals c. That's called standard form. So I know slope is negative a over b. So I'm going to use that rule. The slope 2 is negative a, the opposite of the first term, which would be the opposite of negative 2, which is 2. Over the b term, which is a 1, and you can see those are not parallel either. They're not the same. So writing the equations of lines that are parallel, I want to find out if they're the same slope. So here's the slope is negative 3, so parallel slope is exactly the same. So I'm going to use the slope of negative 3. So in my formula, y equals mx plus b, the m value will be negative 3, and I'm going to plug in the x value to be 1 and the y value to be negative 5. So plugging everything in, I'll get negative 5 is equal to negative 3 times the x value 1 plus b. I'll add 3 to both sides. And solving for b and having the slope, I should be able to write the equation y is equal to negative 3x minus 2. This line is parallel to this line and passes through that point. Negative 3x minus 2 is what the author got as well. Another task that you'll be asked is finding out if lines are perpendicular or not, and the symbol for perpendicular is an upside down T. Here we go. Slope 1 is 4. Slope 2, well, if you divide through by 4 every term, and then look at the number in front of x, that's negative 1/4. So perpendicular means opposite reciprocal, and that's what I have here. And so I would say yes, these are perpendicular. Here I'm going to use the monkeys wouldn't prefer apples over bananas, so it's the opposite of the 2 over the b term. So the first slope is 2/5. The second slope is the opposite of 2 over the b term, and that's not opposite reciprocal. So I would say not perpendicular. For the third example, I'm going to continue using my monkeys wouldn't prefer apples over bananas. There's my first slope. The second slope, since it's in standard form, is the opposite of the first term over the second. This is parallel, so not perpendicular. It would have to be opposite reciprocal. In order for it to be perpendicular, perpendicular slope would be a 2, opposite reciprocal of this. So the last example, the slope 1 is negative 1, and slope 2 is 1, and those are opposite reciprocals. The reciprocal of 1 is 1, but you remember you have to take the opposite, so I would say yes, these are perpendicular. Writing the equation of a line that's perpendicular, the first thing we need to do is find the slope. And remember, I'm going to use the definition, monkeys wouldn't prefer apples over bananas, so here we go, the opposite of the a term, this is in the form ax plus by is equal to c, so using my negative a over b to find slope, I would say the opposite of the a term, which is 7, over the b term, which is a negative 2, so my slope is 7/2. Remember, I need to find perpendicular, so I don't want the same slope this time, I want perpendicular to 7/2, which is the opposite of a positive is negative, and the reciprocal of 7/2 is 2/7. So I'm going to use this slope of negative 2/7. So when I plug it into the formula, my slope will be negative 2/7. And I'm going to use the point, the x value will be 7, and the y value will be 1. So doing the substitution method, I'll fill in by saying 1 is equal to negative 2/7 times the x value, which is 7 over 1, plus b. And fortunately for me, the 7's will cancel. So I'm just left with 1 is equal to negative 2 plus b. Adding 2 to both sides, I'll get b is equal to 3. And then writing the equation using the slope and the y-intercept, I'll get y is equal to negative 2/7 x plus 3. And that's exactly what the author had. The last example is using a word problem to identify the slope and the y-intercept. And here comes the slope. 55 miles per hour is the rate of change. So I know that's the slope. And there's a fixed charge here at 35, so I'll call that the y-intercept. So to write the equation, which is the first question, y equals mx plus b, I would fill in for the slope to be $55 and the y-intercept to be $35. Next, I would take that equation and try to graph it, which is difficult to do. I've changed my x-axis and my y-axis here, but we're not going to get 100% accuracy. It's just a rough guess. So 35 is a little bit below 50, and then I'm going to rise 50 and run 1. So if you'd like to be a little bit more accurate, you can go to your graphing calculators, hit your y equals, and type in the equation 55x instead of the t plus 35. And remember, if you hit second graph, you get an instant t-chart, and then from this t-chart you can find some nice points and plot the nice points. So it looks like 190 is a nice point. 200, oh, that'll fit on my graph nicely. So let's use the 3 and 200. So 190 is a pretty good point. So here comes 1, and 90 is about here. But I really liked that 3, 200 point. So I've got a couple good points. I've got the y-intercept at 35, kind of guessing there, but this is exactly on. There's 3 and there's 200. If you want a more accurate graph, you can look at that. But the purpose of this is kind of statistics. We're plotting points that we know, and now we can make predictions along the line for points that we don't know. For example, we could guess at 2.5. So 2.5 is right here. So we can just come up here and make a nice guesstimate of what that y value would be. But I would go to your calculator and hit trace and ask your calculator to evaluate if letting x be 2.5, the y value is 172.5. Now I can't see it on my graph, but that is actually the answer, 172.5. If you want to see the actual answer, you have to go into your window and change your window view. Maybe I'll only look 5 to the left and 5 to the right, but I need to see up much, much higher. So I'm going to go to my y max and make it go up to 300. So when I trace, I can actually see the line a little bit better. And remember, it's that 2.5 that I was interested in. And so now I can actually see the point, 2.5 comma 172.5. So I think this is what the author got as well. Yep. So don't be afraid to ask me questions about how to use your graphing calculators. If you need some more videos, I'll be happy to create some more videos. So again, writing equations of lines that are parallel, identify the slope by using monkeys wouldn't prefer apples over bananas, -1/2. Parallel slope is the same slope, and then writing the equation of the line. I like to use y equals mx plus b. The y value is 7. The slope we just found is -1/2. The x is a 3. The hard part here is dealing with adding and subtracting these fractions. So I'll remind you to find a common denominator by multiplying this by 2. Makes it a little bit easier to add 3 halves to both sides. And then once you have 14 halves plus 3 halves, is 17 halves. That's the y-intercept. Then we have everything we need. We've got slope, we have y-intercept, y is equal to negative 1/2 x plus 17 halves. Similar process for perpendicular. Just remember, you have to find slope first of all, negative a over the b, and then determine the perpendicular slope, which is the opposite of negative, positive, and the reciprocal. So this time I'm going to be using the 1/2 for the slope instead of the negative 2. And then I'm going to plug in the x and the y. 5 is equal to 1/2 the x term. This is a little bit nicer because half of 2 is 1. And if I subtract off 1 from both sides, I'll get 4 for the y-intercept, and then I have everything I need. Y is equal to 1/2 x plus 4. I hope you found this video helpful. Email me with your questions. Thanks.